This is what it looked like when Hurricane Ian hit Florida in September 2022. 150-mile-per-hour winds ripped apart buildings. Over 10 feet of storm surge inundated the coastline. It tied as the fifth strongest hurricane ever to make landfall in the U.S. Science tells us to brace for more storms like this in the future. That's because hurricanes are forming in an environment that is making them stronger, wetter, and even more destructive. So let's talk about how climate change is changing hurricanes. Starting at the beginning, how do hurricanes form? Well, you need three main ingredients. Number one, warm ocean that serves as the fuel to power a hurricane. Number two, you need winds that are coming together or converging. Tropical winds come together over a warm, moist ocean and water evaporates. It rises up into the atmosphere. Now, as the water vapor rises, it cools and condenses, forming a system of thunderstorms that heat the atmosphere. The heating of the atmosphere causes the pressure to lower, causing the winds to increase and then rotate around the low pressure system. That's ingredient number three. So as the pressure lowers, it causes more of that warm, moist air to spiral inward, making the storm spin faster and faster. Now, once the winds near 74 miles per hour, we often see an eye and a hurricane has formed. It's that first ingredient, warm ocean, where we're seeing some of the biggest climate impacts.
When you think about climate change and warming of the planet, it's not just the atmosphere. Much of the warming, in fact, most of the warming is in the oceans.
Oceans have absorbed 90% of the warming caused by greenhouse gas emissions. And all that excess heat is making the water hotter than ever. In fact, 2022 set a new record for ocean heat content. And researchers say that warming is accelerating and going deeper than ever before. And if warm ocean is fuel for hurricanes, we're going from regular gas to high-octane fuel.
So as hurricanes, typhoons, cyclones come along and tap into that warm, and in some cases deeper warm water, they have the fuel supply to support this rapid intensification process.
Rapid intensification. It happens when a tropical cyclone's winds increase by 35 miles per hour or more within 24 hours.
People may go to sleep to a Category 2 storm and awaken to a Category 3 or Category 4 storm.
Like with Hurricane Ian, it went from a tropical storm with 45 mile per hour winds to a Category 3 hurricane in just 36 hours. And it can happen more than once.
We know that rapid intensification has occurred, and we know it will continue to occur. Some scientific literature suggests that it will increase in likelihood because of warming in the ocean. What I would argue is that from a planning and stakeholder perspective, we have to plan for a generation of rapidly intensifying storms, which means we may need a new playbook in terms of the time frames needed for things like evacuation calls or reverse flow on interstates, for example.
So in a warming world, storms can get strong really quickly, but they could also be more intense in general. The latest IPCC report, aka the biggest climate report there is, says if the world warms by 2 degrees Celsius, global tropical cyclone intensities are likely to increase on average by 1 to 10%. It also projects we'll see a higher proportion of storms reach Category 4 and Category 5 levels.
The environment that the hurricane is in nowadays is simply different than it used to be.
Different because of the warmer water and warmer air that can hold more moisture. More moisture means more rainfall. With a 2-degree global temperature rise, scientists project rainfall rates for hurricanes will increase 10 to 15%. So higher rainfall rates are a recipe for flooding. It's just too much water too fast. Add to that recent studies that suggest hurricanes may move slower in the future, and you've got a storm dumping water over the same area relentlessly.
Been a number of storms in recent times that have moved quite slowly. A classic one was Harvey.
Hurricane Harvey unleashed over 50 inches of rain over parts of southeastern Texas. The storm meandered along the Texas coast for days. Researchers have found fingerprints of climate change in Harvey's rainfall. How? Well, attribution studies. Scientists use a combo of historical data plus modeling analysis to see how the weather event would have unfolded if not for climate change. In the case of Harvey, researchers say climate change made the storm's rainfall 15% heavier and 3 times more likely.
One of the trends which is most robust is that we get more heavy rains out of these things, and if we can't manage those and store the water in the right places, then the prospects for flooding and for damage And and these storms normally would cost a couple of $1 billion, but instead they're costing $50 or $100 billion.
Hurricane Harvey came with a price tag of $151 billion in damages. Now that's the second costliest storm on record. Hurricane Katrina is the costliest at $190 billion. Hurricane Ian ranking third with $112 billion in loss and damage costs. Another thing these storms have in common, well, water-related fatalities. Water accounts for about 90% of direct deaths during a hurricane. Now that comes from rain and flooding and storm surge. Storm surge is what happens when a hurricane pushes ocean water on shore, flooding what is normally dry coastline with sometimes feet of water. It's just another hurricane risk that's getting worse with climate change. Now there's two factors to unpack here. The first is thermal expansion. You see, water expands as it warms, and as oceans absorb more heat and get warmer, the water expands. That's contributing to global sea level rise. Combine that with higher storm surge from future stronger hurricanes, and you have potential for storm surge moving miles inland. In a warming world, the science points to stronger storms with more destructive surge. That's why researchers at Florida International University are building a facility that will simulate a hypothetical Cat 6 hurricane. They'll test how homes stand up to 200-mile-per-hour winds and 20-foot storm surge.
The ultimate goal, of course, is to design a home that is resilient to these hazards. That's what we're after, to make a home stronger, to understand the impact, and be able to design safe homes.
And that's what we call climate adaptation. It's something we're going to need a lot of as climate change alters the environment and the conditions that hurricanes form in. Thanks for watching. Like and subscribe for more climate science content like this and solutions.